Now these two equations, what do they represent? This is linear equations in two unknown variables. If I replace x1 by x and x2 by y, what do these two equations represent? What do these two equations represent geometrically? Coordinate geometry? Answer? Anyone can answer?
Simple lines, sir.
Yes, good. Each of them represents straight lines. So these are two straight lines. All right. So geometrically, these represent straight lines. Okay. Now, let us plot this. I will have three cases. Okay. Maybe I'll make it small. So I will try to use all the three cases. So x1 on the x-axis, x2 on the y-axis, x1 and x2, x1 and x2. So x and y basically. So we have these three cases. Now the first case is that delta is not equal to 0. That means, what is delta? See, delta not equal to 0 means I get a11 a22 minus a12 minus into a21 is not equal to 0, which implies take this to the other side and bring one over the other. A11 by a12 is not equal to a21 upon a22. You just see here in straight lines, if you remember your intermediate level coordinate geometry, if the coefficients of two straight lines are not in proportional ratio, that means say a11 by a21 are the coefficients of x1. So ratios of the coefficients of x1 divided by the ratios of the coefficients of x2, they are not equal. Then what does it mean? They are non-parallel lines. They are non-parallel lines. In fact, the slope is minus coefficient of x1 by coefficient of x2. You can show that this is also implies a11 by a yeah, these are slopes only. A11 by a21 and a12 by a22, both are same. These represents proportionality of coefficients. and this represents slope. If you apply minus sign, it is slope. That means slope of the first line is not equal to the slope of the second line. So delta not equal to 0 is a case of non-parallel lines. Non-parallel lines. So for non-parallel lines, you will have a unique solution. Simple. Okay. Two non-parallel lines intersect at a unique point. Okay. So you get a unique solution. That's our first case. Got it? Geometrically. Now what happens in the second case? This is case 1. Case 2. Here all the determinants are zeros. You see delta equal to 0, delta 1 equal to 0, delta 2 equal to 0. Here in this case, delta equal to 0, delta 1 equal to 0, delta 2 equal to 0. So what you get if you observe A11 by A21 is equal to A12 by A22 is equal to B1 upon B2. How I get this? Equate each of these determinants to 0. This is delta 2, equate to 0. So you get A11 into B2 is equal to A21 into B1. So A11 by A21 is equal to B1 by B2. Here we get A12 by A22 is equal to B1 by B2. So we get this. This is a case of two lines. They're not just parallel to each other. They are also coincident. These are two coincident lines. These are two coincident lines. So they have infinitely many points in common. Okay. You have infinitely many points in common. So the second line I will mark with these are two lines, but they are coincident lines. One over the other. Got it? Now third case, what will that be? Delta equal to 0, but not equal to delta 1 and not equal to delta 2. Okay. So delta 1 and delta 2 are not equal to 0. So you get A11 by A21 is equal to A12 by A22, but this is not equal to B1 by B2. These are case of two parallel lines. This is non-parallel lines. Sorry, no parallel, non-parallel lines. Okay, two parallel lines. So this is the first line. And okay. This is a second line. So two parallel lines, they will never intersect. So they will never intersect. So no solution. So you get unique solutions, unique point of intersection or unique solution, and many points of intersections, infinitely many. And no solution. That means no point of intersection. Clear?